Exercise 39 asks that we identify an inequality that represents x in centimeters. And then we're also given this picture of a rectangle that has one side labeled as 10 centimeters and the other side labeled as x. And we're also given the information that area, and we have to assume that this is the area of this rectangle, is greater than or equal to 120 centimeters squared. So that means x has to be a value that, when multiplied by 10, gives us an area that is equal to or greater than 120 centimeters squared. So some of you guys might just be able to knock this out in your head, but I still want you to do it systematically. How do we determine the area of a rectangle? Well, the area of a rectangle is the length of the rectangle times the width of the rectangle. And so that's how we're going to determine the area expression that's going to be on the left side of our inequality. And the length of this rectangle, well, that's x. And then the width of the rectangle, that's 10 centimeters. And if you thought about it backwards, it's still the same concept, still the same, going to give you the same answer. So our area is equal to the expression of x times 10, or 10x. Because 10x is a different way of saying 10 times x. And then we want that area to be greater than 120 centimeters squared. We want it to be greater than or equal to 120 centimeters squared. So what you really needed to know for this problem, because as you can see, we just solved it out together, what you really needed to know for this problem was that to find the area of a rectangle, that's going to be multiplying the length times the width. So that geometry, and is something we are going to visit in the future, with a little bit more complicated than that, but it is something you need to know for all of your material from here on out. And then it also asks that we give the solution for whatever inequality is that we choose out of these four. And so what that means is that you're going to solve for x. I still see some people not putting the x and the less than or equal to, or the greater than or equal to, whatever it is. So make sure you're putting all of it for the solution, because the solution isn't going to be just one number. Let's say you said it was 5. Well, it's not going to be just 5. That would be true maybe for an equation, but for an inequality, it's got to be maybe greater than 5. So that's 6, 7, 8, 9, 10, all the way to infinity. Or maybe it's less than 5, less than or equal to. But the solution isn't going to just be 5. That would be if we were working with equations. Exercise number 40 asks the same kind of problem. We are being asked to identify an inequality that represents x, with x being the height of this rectangle, of this triangle. We're being asked to identify an inequality that represents x, the height of this triangle, and we're told that the area of this triangle is less than 20 feet squared. So what you need to know for this is that the area, and this one might be a little something not so fresh in your mind, is that the area of a triangle is 1/2 the base, or 1/2 times the base, times the height. So let me show you an example using the same kind of problem they've got here. Let's say that I had a height of 2 and a base of 10. Then to find the area of this rectangle, I would do 1/2 times the base, 10, times the height, 2, and then 1/2 times 10, that's 5, because half of 10 is 5, times 2 is back to 10. So the area would be 10 whatever units squared. And so now here you don't know the height. So what I would do if I didn't know that the height was 2 is that I would plug in x in for 2 here. And then that 1/2 and that 10 I could still multiply. But then that would leave me 5 times x, which would just leave me 5x as my area for this triangle. So it'd be a representation of the area rather than the actual area. And so you're going to use that same kind of technique to solve for exercise 40. Just remember, this is just an example, not the actual problem. Don't try to find that on your solutions. And then that has to be less than 20 feet. Well, they all have less than 20 feet, so that's not something you have to solve out. That's something that's already there. And then the solution is, well, in this case, I would put that the solution, if this was less than 20 feet, I would divide both sides by 5 and say that x is less than 4. And I would put here x is less than 4 for my example. So just make sure that you are including the x and everything in there, the inequality sign as well.